This is the study guide for the test on statistics for Algebra 1. I'm going to go through this study guide, answer some of them. The first part kind of details the things that you need to know. Let's get into the nitty-gritty of actually solving some of these questions. So the first question talks about box and whisker plots. They kind of spoon-fed you with this box and whisker plot question because they even labeled the lower extreme, the lower quartile, the median, the upper quartile, the upper extreme. A says, what is a range? Your range is 100 minus, looks like, let's say 17. So let's say that's 83. Make sure you find the range of the box and whisker plot, not the range of the line. What is the interquartile range? So again, let's say 87 minus 51. Let's say it is a 36 for our interquartile range. What fraction of the time was between 51 and 68? 51 and 68 is 25%. I'm sorry, it says fraction, so it's 1/4. What percent between 18 and 87? 18 and 87 looks like 1, 2, 3 sections at 75%. What is the value of the lower quartile? Lower quartile is, I'm going to say it's 51. What's the value of the lower extreme? I'm going to say that's, this was 18 here, we'll say 18, which means this might be 82 if that's 18. What is the value of the median? Let's say, again, based on that information, 68. What fraction of the time did the account have 51 or less? So here's 51, 51 or less. That's 1/4. Which quarter has the data most spread out? In other words, what's the biggest section? Looks like the first section. So from 18 to 51 is the most spread out. Which quarter has the data most clustered? I think this is the smallest one, which we'll say is 87 to 100. What percent of data falls between the upper quartile and the upper extreme? Well, that's always 25%. It doesn't matter. I don't need a box and whisker plot to answer that one. Don't need a picture for that. What percent of the data is greater than the lower quartile? Well, again, don't need the picture to know that greater than the lower quartile. So this, and this would be 75%. Question 2 looks like it has 2 parts. Part 1, the chart at the right shows the scores. Using this chart, create a stacked box and whisker plot to compare Sam and Mary's math grades. All right, so you're not actually going to be responsible for creating a box and whisker plot on the test. Let me show you how to create a box and whisker plot. The first thing I'm going to do is put this data in order for Sam and Mary. Now that my data is in order over here, I essentially need to find the 5 values that will create lower extreme, lower quartile, median, upper quartile, upper extreme. Let's start with Sam. Here's my lower extreme and upper extreme. Let's find the median by going in by the one that's 85. Now I got to find the lower quartile, which would be somewhere between 76 and 83, which would be a 79.5. And then over here, midway between these two, which is an 89.5. Let's do this now that I have these values. I can start with 65. Since it's stacked, it means one on top of the other. I'll go high. 70, 65, 79.5, 85, 89.5, and then 95. Make my box, little boxes. And 2 whiskers. Let's do the same thing for Mary. I'll do a different color so you can see it. In lower extreme and upper extreme, I'll go in until I find the median, which is 85. The lower quartile is 81. Go in. The upper quartile is 87.5. Make these 78. Then 81. And then 85. 87.5. And 95 also. Not very good box. There we go. This is my stacked box and whisker plot. Part 2. Let's answer these questions down here. Part 2. The range is less than Mary's range. Well, Sam's is clearly more spread out, and they start at the same spot. So I can subtract to find it out. That would be false. The mean for Mary is the same as the median for Sam. All right, well, based on the box and whisker plot, I can't find the mean. I can find the median for Sam. The median for Sam I know is 79.5. But the mean for Mary, I actually have to calculate that. So I take out my calculator and find the mean by adding them all up. We can do that very quickly. When I'm done calculating, I add all these guys up. Divided by 7, I got the average for Mary was 85. So it's clearly not the same. That's also false. C, Mary's mean is less than Sam's mean. So I found Mary's mean, which is 85. Now I gotta find Sam's mean by adding them up and dividing. Sam's mean turned out to be an 82, so again, this is false. Mary's median is higher than her mean. Well, her mean and her median both appear to be 85, so let's check this over again and see what we messed up. Well, as far as I can tell, there are no mess ups, so which of the following is true? None of them are true. They all are false. 3 is on the stacked box and whisker plot, except they already made it. The stacked box and whisker plots involve track the stock performance of 4 leading companies. Which company holds the record for most stock sold? How many did they sell? Well, most stock sold looks like it's right here, which would be company D, sold around 4,750. Which company has the greatest median amount of stock sold? So this one has the highest median, which would be company C. Number 4. More stacked box and whisker plots. The box and whisker plots above compares homework time and TV time for a class of 8th grade algebra students. Which statement is false? The upper quartile for homework, the upper quartile for homework is the same as the median for TV. Well, that's true. The upper quartile for this is the same as median for that. That is true. The interquartile range for TV time is less than homework time. You're saying that this distance is going to be less than that distance? No way. That's also false. You can find it by actually subtracting. Again, the interquartile range is the range between the quartiles. It's not just 50%. We know it's always 50% because it's 25 and it's 25. The actual interquartile range would be 110 minus 15. Actually do the work, and this would be 60 minus, looks like 20. Again, false. C, the range for TV time is greater than the range for homework time. The range for TV time, so from here to here, is bigger than homework time. Definitely bigger, so that is true. And the mean absolute deviation for homework time is most likely less than the mean absolute deviation for TV time. Mean absolute deviation, as you know, is how the data is spread out. So you're saying the data is more spread out for homework? Certainly not, because you can see it's a tighter bunch. This starts at 0, goes up to 190. This starts at 0, goes to 223. This is bigger. This is tighter. So everything about TV time is larger, so the mean absolute deviation is going to be larger for TV time. That's also false. Excuse me, that's true. This reading it is most likely less. Yes, it's most likely this is going to be smaller than this spread. So this is most likely less. So this is true, this is true, this is true. Which one's false? That would be choice B. Again, this one's not more spread out, so it is true that homework time is most likely less spread out than TV time. Moving on to some other statistics type stuff away from box and whisker plots. Question number 5 says to find the mean absolute deviation, variance, and standard deviation for the data sets below. Let's do each one individually. We'll start with 12, 18, 25, 10, and 50. In order to do this, first thing I want to do is need to find my average. I can't find the distance away from the average until I find the actual average. So I have to find my mu, or my mean, or my x bar of these 5 numbers. To find the average, add them up, divide. You get 25 as the average of the mean of the x bar of the mu. So that's part 1, find the average, the mean of the x bar. In order to find the mean absolute deviation, you cannot use your calculator, but what you can do is just figure out the distance away from the average. That's essentially what the mean absolute deviation is saying, how far away from the average on average. You could do the whole absolute value thing, but you know above or below, distance is always positive. That's what absolute value is talking about. From 12 to 25, that's 13. From 18 to 25, that's 7. From 35 to 25, that's 10. 10 to 25 is 15. And 50 to 25 is 25. Somewhere below, above, somewhere below, it doesn't matter. It's mean absolute deviation, absolute in absolute deviation stands for absolute value, which is the distance from 0. So it's divided by 5, that's 40, 50, 70 divided by 5, which is 14. That's my mean absolute deviation. To find your variance, it's the exact same thing. The distances away, so I can just rewrite those same distances. The only difference is each of these numbers are squared. So we follow order of operations and square each of those numbers. 13 squared, 169, plus 49, plus 100, plus 225, plus 625. Divide that by 5. That will be my sigma squared. Let's see what we get when I add those all up and divide by 5. I have 1,168 divided by 5, which is 233.6. Now that's sigma squared. That's called my variance. In order to find my standard deviation, which is sigma, sigma is the square root of sigma squared. So in order to find sigma, I take my sigma squared, which is 233.6, and square root those, and sigma equals the square root of standard deviation equals the square root of 233.6, which is 15.28 approximately for the first one. Now, of course, you can find some of this information in your calculator. How we find this in your calculator, this one's going to be slightly different, is you're going to hit stacked. You got to edit your list, so you hit enter or the number 1. Either one would work. Now, in my list 1, I'm going to plug in my numbers. I'm going to plug in my original orange numbers. So 12, 18, 35, 10, 50. And once they're in there, it cannot find the mean absolute deviation, it cannot find the variance, but it can find the standard deviation, and it can find the mean. So here's how you do that. You once again hit stacked. This time we're going to move over and go over to calculate by going over. Now I'm going to hit my one variable stats. I'll hit enter. Sometimes you have to hit multiple times and enter. This time it gave my x bar or my average, which was 25, which I knew. Some of these don't make any sense to you, but here's again standard deviation, sigma for x, 15.28397, which I rounded to 15.28 down here. How can I use this number, though, to get my variance, or sigma squared? Well, take this number and square it. So you do 15.28397854 and square that. Now, of course, it won't be exact because it's a round, but it was pretty darn close. In this case, it got it 233.6, which is what I got by hand. So your calculator is a checking tool. You should use it to check. Going back to the actual study guide, let's do part B. 96, 82, 100, 90, 71, and 83. First thing I have to do is find my average, my x bar, or my mu, which is add them all up and divide. And my average is an 87. To find the mean absolute deviation, they go the distance away. So 9 to 87, that's 9. Sorry, 96 to 87 is 9. That's 5. That's 13. That's 3. That's 16. And that is 4. Divide by 6 because there are 6 of them, which is 50 divided by 6, which is 8.3 repeated. This is again the mean absolute deviation. To find my variance, or sigma squared, it's literally the same numbers, except you square each of them first. Remember to square them first and then add. So it's 81 plus 25 plus 169 plus 9 plus 256 plus 16 divided by 6. That would be my sigma squared. When I add all these up, I get 556 divided by 6. So my sigma squared equals a 92.6 repeated. How do I find my sigma? Well, I just take the square root of that. And that's a 9.63. Let's round to the hundredths place. So I should be rounding this by having my approximate. How do I do that in the calculator? Now, if you go to stat again and hit edit again, you'll have this whole list. Don't hit delete, it's very dangerous. Or you should go up to the very top, and again, don't hit delete, you'll delete the whole list, and then we can't help you. Hit clear out the list, then go back down, it should be all cleared out. And then from there, you can type in 96, 82, 100, 90, 71, 83. Looks like I missed 71, so it's 71. So I have my 6 numbers, stat, calc, divide by 1 variable stats, and this time you can see I get my average is 87, 9.626 was my standard deviation. The third question had much bigger numbers and more of them, so let's do the third part C, 5C. Once again, find my average, my mean, or my x bar. Add them all up and divide. Average is 484. Find the distance away from 484, which would be 34, 1, 16, 73, 102, 66, 36, and 9. Divide by 7 because there are 7 of them. Let's add them all up first. That's 436 divided by 7, which is 62.29 equals my mean absolute deviation. You notice that there's a much higher number than there was before, and the reason it's higher is because these numbers are more spread out. Mean absolute deviation is how far away absolute value you deviate from the mean. These are much more spread out, that's why there's a higher number. To find now my variance, my sigma squared, I did the exact same numbers, but I squared each of them. And so this is going to be some messy calculations. So I'm going to do it all in my calculator all at one time. In other words, I'm going to do, in parentheses, because the entire numerator, 34 to the second power plus 116 to the second power plus 73 to the second power, got to be careful, plus 102 to the second power plus 66 to the second power plus 36 to the second power plus 9 to the second power. Divide that entire thing by 7, and we get an answer of my sigma squared is 366.7.92. Sigma squared is 366.7.92. To get my sigma, I square root that, the second square root of 366.7.92, and that is a 60.56. So let me just check to make, oh, these guys are about the same number, so it makes me feel like I actually did it correctly. My variance and my standard deviation. Now, if you look at 6 requires you to use 5C for some of our answers. Now, 5C, let's take some of my values from 5C, because I need some of that to solve 6. It says, suppose the data represents the SOL scores for some students. Find the z-score for each of these scores above. Now, in order to do the z-score, we know that the z-score, I'm going to do my work right here, z equals x minus mu all over sigma. So in order to find my z-score, x represents a score, so for the first one will be 450, minus mu, which is the average. Now what was the average? If you remember, the average was 484, so minus 484, all over sigma, which was my standard deviation, which we calculated to be 60.56. 60.56. To do this, this would be negative 34 divided by 60.56, which is approximately equal to negative 34 divided by 60.56, negative 0.561, we'll round it to. That's the first one. I would have to do the rest for all of the rest of them. I would do again the next one. Z equals 600 minus 484, all of the standard deviation, which is 60.56. In this case, it's 116 divided by 60.56, so it's going to be positive. 116 divided by 60.56 is a 1.915 for the second one. I would do the same thing for all the rest of them, continue going through them, and that's how you find the z-score for each of them. Let's do one more to make sure it sticks in there. Let's randomly choose 550. Again, my z-score equals 550 minus the average, which is 484, divided by the standard deviation, which is 60.54. Notice that everything stayed the same, except for what my x or my element was in my z-score formula. This is 550 minus 484. So that's 66 divided by 60.54, which is a 1.090. Next question says, how many of these scores fall within one standard deviation of the mean? Now, one standard deviation means the z-score equals between -1, so it's less than or equal, sorry, let's do it this way actually, not less than. The z-score is bigger than -1, so within 1, tighter than 1 on either side. Z is not smaller than -1 and not bigger than +1, so somewhere between them. This is an example of one that falls within that because the z-score is between -1 and 1. It could be 0, it's -0.5 in this case. This one's too big, it's on this side. This one's too big, it's slightly on this side. But the other way we could have done it is if we know it's within one standard deviation of the mean is 484. So how far would it have to go to this side? Well, one standard deviation is 60.54. In other words, 544.54. And this way would be minus 60.54. So that would be 423.46. So somewhere between those two in order for you to be within that range. So let's see. This one falls between 423 and 544. This one's too big. This one is too small. This one is also too small. This one's slightly too large. This one, 520, that fits in that range. And 475, that certainly falls within that range. So how many? 3 of them fall within that range. How many standard deviations are required to contain all of the data? Well, the furthest one away, if we look at our score right here, was 116. That's the furthest one away. 116, which we actually did this one, was 1.915 away. So how many standard deviations are required? If you go 1.915 on either side, or if you want to round it to 2 on either side, that would contain all of the data. 2 on one side, and it should be a little less than 2 on the other side. Question number 7 talks about Alice and Martin in the same French class. The following represents the class scores for the test. Find the average and standard deviation. Well, I'm going to find the average and standard deviation by plugging into my calculator because it's a little bit more efficient. So I'm going to hit Stat, Edit. I'm not going to hit Delete. I'm going to go up to the top and hit Clear. I'm going to hit Clear, and that'll clear it out. Excuse me, sorry. Clear, and then hit Enter to go back down. Sorry, Clear and then go back down. That'll clear it out. Now plug in all these numbers. And once I have them all in there, I'll find my mean and standard deviation by doing Stat, Calc, hit Enter. Hit Enter a couple times. My average is 83.75. My standard deviation is 9.867, we'll say. So my average is 83.75, and my standard deviation, I'm sorry, I put it in the wrong spot. My average, my mu is 83.75. And my standard deviation is 9.867. I'll round to the nearest thousand. Alice's test score was 97. How many standard deviations is her score away from the mean? How many standard deviations is another way of saying the z-score, x minus mu all over sigma. So as an element, which was a 97 minus the average, which is an 83.75, divided by the standard deviation, which we'll call 9.867. When I do this work, I get a second quit. I'll just do 97 minus 83.75 equals, got to get the numerator first, divided by 9.867, and that is a 1.34, we'll call it, a 1.34. Martin scored 0.89 standard deviations below the mean. What was his test score? So again, standard deviations away is the z-score. Z equals x minus mu all over sigma. The difference is this time they gave us the z, which is 0.89 below is the negative 0.89 equals the x, which is what we're looking for, minus the average, 83.75. over the standard deviation, which is 9.867. This is an equation you should be used to solving. We solved several ones like this before. Multiply by 9.867. Multiply this side by 9.867. On the right-hand side, we have x minus 83.75. On the left-hand side, we have the product of 9.867 and negative 0.89, which is negative 8.78. Negative 8.782, we'll call it. We solve this by add 83.75, add 83.75. X equals, let's do this, take that, add 83.75, and we get what Martin got, which is a 74.97. 74.97, or more likely a 75. Either one of those would probably call the correct answer, one of those two. Last question we'll do for this one. Question 8, Barbara took 2 tests. On her English test, she got a 38. The average was a 35, and the standard deviation was 0.5. On her physics test, she got a 52. The average was 49, and the standard deviation was 0.8. On which test did she do better? It's really relative to her classmates. On which test did she do better? She did better on physics. But relative to her classmates, we take the average and the standard deviation into account. Let's start with English. Let's find her z-score, x minus mu all over sigma. So her z-score is her score, which is 38, minus the average, which is a 35. So she's above average, divided by 0.5, which is the standard deviation. This is 3 divided by 0.5. Divided by a half is not 0.5. It's not divided by 2. 3 divided by a half is actually 6. So she was 6 standard deviations above, which is pretty darn good. Let's do now the physics test. Again, it's the z-score is her average, her element, 52, minus the average, which is a 49. So she was 3 above also. The difference is the standard deviation was 0.8. So it's 3 divided by 0.8, which is approximately equal to 3 divided by 0.8, a 3.75, which is also very good. She did very well on both of them, but she did much better on the English test because she was 6 standard deviations above, as opposed to just 3.75 standard deviations